Filter sets are an important capability of the Process Mining Analyst Workbench that might not be worthy of an entire Process Mining Academy session, but definitely deserve a community post to raise awareness and make sure that everybody knows what they are and how they can be used. Now, any sort of analysis you're doing is like having a conversation with your process data. You ask the process data a question, it gives you an answer. Based on that answer, you ask it a follow-up question, and on this goes until you get to a place where you have some form of actionable insight. As you're having these conversations with the data, there might be a certain line of questioning that you want to bookmark, save for later use, or consistently come back to every time you refresh the data behind the process mining model. These are exactly what filter sets are for. So let's just do walk through a couple of different examples and to show you, how to use them and maybe a couple of different use cases. So the first thing that we're going to do is come over here. And very often what we like to do is compare certain slices of the data to our ideal path. How well are we conforming and what's the impact to these adverse scenarios? So one way to get to your ideal path is to come in here and sort your variation analysis by the most records. And that's going to give us the different routes that were taken most often. If I scroll through these, what I'm going to see is I have this path of new, assigned, in progress, resolved, and closed. And that's the way that work is supposed to move. So maybe I want to narrow it down to just these. So I have my ideal path. And what I'm going to do now is I'm going to use my filter set here and save this filter set as my ideal path and hit save. And now what I have is I have this filter set, my ideal path, and I get the statistics for that path. Every time I remind this project, this process mining project, I'm going to have this filter set available to me, and I'll be able to see how many records are aligning to the ideal path that I designed for that set of data. So if I come and I change the filters that are inside of the project to look at, let's say, the whole quarter versus last month's worth of incidents in this case, I will see this ideal path and get the stats about that ideal path for this filter set. Very handy to have that to just quickly jump back to every single time. Now, maybe what I want to do next is I want to start to compare and see the impact of things that go into the awaiting caller state versus my ideal path. So I've got my awaiting caller state here. What I can do is I can come and investigate, hit filter on transition, and this is not going to narrow it down to the incidents that go into the awaiting caller info state at some point during their life cycle. And what I'll do next is I'll just come here and I'll save a filter set that say incidents that go to awaiting caller. Save that. And now I have a filter set that shows me these 8,200 records or 8,173 or 38% of my incidents go into the awaiting caller state at some point in their life cycle. Now, what I can do is now that I have these two filter sets, I can come over here and on the left-hand side, I can say, show me my ideal path. And then I can come over here and use my compare. And I can bring up filter sets again and say, let's compare incidents that go into the awaiting caller state versus my planned or ideal path and see what the impact is. So I can use the comparison statistics. I can see on average, things that go into the awaiting caller info state, they take on average 3 days and 2 hours longer than the things that are going through the path as with the ideal path, the straight line through. So that's just one way you can use the filter sets to save different slices of the data and then use those filter sets to start comparing them to one another, different slices of the data to one another. There's several other ways you can use filter sets, but I think you get the idea now. Happy mining, everyone.